So in the last 3 or 4 problems that we've done together in the U substitution section, there has been no issues coming up. Everything worked out beautifully and everything worked out nicely. It was very straightforward, very clear. But that's not always the case. So this is the issue with this next problem. Even though it's going to be a U substitution, it's not going to be a very straightforward U substitution. So let's begin like we did previously. The thing I'm noticing here is that there's a fraction. So let me write down the problem. It's got x squared on the numerator. It's got x cubed plus 10 on the denominator. And then there's the dx. So the problems that have fractions, typically speaking, the u has to be the denominator. So in this case, x cubed plus 10. That's because the original fraction cannot be divided out. There's nothing I could do to reduce it, basically. So I'm going to grab the denominator and call it by a new name, call it by the name letter u. Once I do that, the next step is to find the derivative of both sides. So what's the derivative of the stuff right here? X cubed becomes 3x squared. The derivative of 10 is nothing, it's just 0. So I'm going to erase it and I'm going to write it. And then the dx at the end. So this is my table that allows me to now make the substitution. Now it is important to notice right here that we need 3x squared and a dx to put in one single letters du. One single quantity of du equals 3x squared dx. Now, do we have 3x squared dx in the original problem? The answer is no. We have x squared dx. We don't have 3x squared dx. So that is an issue. That is a problem. So the problem that we have is missing a 3. It needs a 3. It already has x squared. It has a dx. It has x cubed plus 10. But the 3 is missing. So since the 3 is missing from the original problem, here's what we're going to do for this one. We're going to just write a 3 there. That's the 3 that we want. The one that's missing, we're going to put it. We need a 3 on the numerator next to the x squared, next to the x. So let's just write it there. But you can't just do that. That just changes the problem completely. So how do you keep things balanced? You just put a 3 on the opposite side on the outside. So since the 3 was on top, I'm going to put 1 on the bottom across from it. So technically, I'm keeping things balanced because technically the 3 and the 3 cancels out if I wanted them to, and they go away. I go back to the original setup. But obviously, we don't want to cancel them. We just want to use one of them to create the du.